You're probably gonna have to go to your displays and make sure you're
Yeah.
hooked up.
Yeah. Just a second. Hey, morning. Hey, morning.
And if you're, if you have any audio, you gotta grab a.
Audio for your laptop. If you have any audio. Okay. So let's go ahead and open up a web browser and log you into Opto, and you can start doing a screen capture into that recording because I just started the recording.
Okay.
So oh, I misspelled it.
That's a good here. Oh, yeah. Right on. Really? Yeah, sorry, I'm just on handout.
Morning.
Morning.
How are you?
Left?
So
Yeah.
Hopefully just the focus.
so we're actually going to turn off your video and microphone. Well, microphone we'll have to keep on because we're picking up audio from here into the recording, so we don't need it. So it's just going to be a screen capture primary.
Okay.
And do you have a PowerPoint or a Keynote?
Yeah, you know.
Okay. And that's it.
Used to work for Apple, right?
Yeah.
Has to have a keynote.
And then all I needed to do. Oh, and
Resolution?
yeah, you can just exit out or minimize all of this, and then I'll make sure that it's.
It's like blurred.
Oh, I think that's the projector, unfortunately. I don't know if there's anything, because it's an HD.
I saw you. That's lots of
Yeah, I haven't used this in a while, and it was too old. Cobwebs and stuff. That's unfortunately, that's as good as it gets with the focus.
Really?
I think it's just the resolution of the projector that they have in here. Is that
Okay, awesome.
No creo que lo use. Could do loading. Oh, nothing wrong.
Good.
It doesn't like doing that.
Resolution could be this.
Do it just.
In the better only 75 year creation the 50 years.
Let me know when you're ready.
I think you should do it.
Yeah.
You ready to go?
Yeah.
Okay. Good morning. It's 9 o'clock and it looks like we have a full house. My name is Brett Bendixson. I'm with the integration team in UITS. If anyone didn't sign in when they came in, just make sure you sign in on your way out. We have a lot of new technology to learn about today from Srini Vemula, application systems analyst, developer at UITS. And I'll let him take it away. Thank you.
Thank you. Good morning, everyone.
Thank you for your time. The very fact you came here for 3-hour session, definitely expect something. I'm not going to disappoint you. Rather, I'll be making it surely interesting for you. And also, something you learn. So I think few more folks will be joining us. Just a few minutes, we'll do some housekeeping. So, thanks to that for introducing me, Srini Vemula. I'm with UA Admin Technologies last 8 months. I was there 17 years in the Silicon Valley. Worked for Apple for 5 years, 6 months for another company, and a lot of other companies. Mostly last 4 years I've been working on big data, especially on whole stack. So I have my associates here. Can you please get up?
Hi.
Kiran and Andy and Shiva. They will be interacting with you so that you don't have to wait for me and have small glitches. So definitely the topic is very big. Some people haven't registered because, hey, they can't do it in 3 hours. Of course, we are not covering everything. Rather, we are going to uncover. We are going to uncover. We are not covering. We are going to uncover and take it to the, help you to go to the next level. So, our focus will be on this topic. If you think by mistake you came here, please check the topic. And maybe in some other room, there may be some other workshop. If by mistake you dropped in here. We can make this topic productive only if we collaborate. If we just watch as a movie, we can't make it. It's a workshop. So we all need to work. Welcome. So without knowing your name and without interacting with you, we can't make it productive. But at the same time, we cannot go one by one in the very first few minutes because it may take 20 minutes to introduce all of us. No, we'll make it as a work in progress interaction. So feel free to ask me any questions. Also expect questions from me and my associates. Okay, so it doesn't matter how much you know or how much you don't know, it doesn't matter. So focus on getting the concepts. So let's see here. The discussion is, I want to make sure, I want to take a few minutes, set the agenda, and what is going to be covered in next 3 hours, and when we'll have a break. Okay. So see, programming. So this workshop is more on programming. So get ready to start coding. So of course I'll be helping you. A big data unified. So we'll be talking definitely about some big data concepts. But if you see mostly unified Lambda architecture solution. So definitely you need to, what's your good name, sir? Steve, great name. So we'll be understanding unified Lambda architecture solution. So you can't program some architecture without knowing what is that architecture. So we need to know what is this architecture. Then we'll be using these tools. Tools are software. Let's call them as software, not tools. Tools means Excel, PowerPoint, Keynote. Some ETL tools. But these are full-fledged softwares. Full-fledged softwares. Apache Hadoop was given by originally Google as a Google file system, and they opened, so they gave the specifications, and Yahoo, along with few people, created wonderful software and open sourced. And this is a de facto standard for big data now, for storage. Last 10 years, Hadoop also used to do computing. Whenever you talk about computers, you have a storage and computing. Is that right, Iqbal? Right. So Hadoop used to do both storage and computing. Anyone know what is that computing? Hadoop does? Steve? Yeah.
Doesn't it do only batch processing things that can be executed in parallel? It can't do sequential things?
That's correct. But it's a MapReduce. MapReduce, you might have heard. But MapReduce is going to go away. Almost, it's there. It's aged. So that's where new computing softwares came. Apache Spark. It's originated in UC Berkeley. It's a cluster computing platform, very powerful and written in Scala. We'll talk about it. Then we'll be also interacting with Apache Kafka. As Steve said, Hadoop does only batch processing. But nowadays, a lot of things are real time. Yeah, we have definitely some research developers, research associates who might be doing studying about brains, studying about DNAs. There may be times you may be doing MRI. In the real time, you want to capture what's going on there. Or you are doing a connected car or IoT, where you want to know the data, how it is streaming and what's happening. Steve, have you ever tried for entrepreneurship?
No.
Business? You have any plans in the future? Why not, you say? Because nobody knows future, right? So, yeah, see, you may be launching a product. When you launch a product, whether it's doing good or not, how you know? You don't have to go for survey. Nowadays, people talk about in the Twitter, Facebook. So what's happening? The conversations there, you can able to pull. When iPhone launched, it has a antenna gate a few years back. Steve, you know that?
What is it?
Antenna gate. iPhone 4, when it was launched, it has antenna. They made it aside.
Okay.
When you hold and start speaking, you can't hear properly. That was antenna gate. So it became a big news. Steve Jobs was there in China at the time. He has to flew back. And finally they found a solution. But how they come to know? Everyone talking on the Twitter, somebody posted, hey, I'm holding this, my signals are getting dropped. That was a big, it costed, its share price dropped a lot. So anyway, real-time big data is a big. So that's where you will be understanding today how Apache Kafka is going to do the streaming, and Apache Spark, how it is processing. I'll make you understand. Finally, Apache Cassandra. Everywhere we see Apache, it's becoming so famous now, open source. Apache Cassandra. Cassandra is a nice name. Anyone knows about Cassandra? Apache Cassandra? But no. You haven't Googled before coming to class? If you Google it, Cassandra, you'll get a Greek queen. Cassandra, then you will be coming to class thinking that this guy is going to talk about Greek life. Huh? I missed when I was in college. Okay. No, this is a software, sir. Okay. It has its own great things we will be talking. So this is the agenda. Yes, sir.
Is it NoSQL database?
It is. That is correct. It is. NoSQL, one among many NoSQL databases. It's very famous. So if you see anyone, it's a very daunting, isn't it, Steve? Okay. A lot of people told me it's not daunting for me because I'm not experimenting on you. I've been sharing a lot of this knowledge for many people for many years. It just only changed. I used to have a mustache at the time. Okay. So this guy is the Renard. He wrote the software Apache Spark. So I used to meet him in the Hadoop conferences. And I also help kids on the coding classes and something related to science, math, and art, how we connect them. So definitely I'll make it interesting for you because there is always a kid in you or in us. Okay, wonderful. So this is the agenda. So we'll be going like this. So first let me come here. What is that, Steve? Again, because I know only your name. Slowly I'll be coming to know. What is this? Let's talk about this.
That is a drink with ice cubes.
What is that?
I don't know. It's a bubble tea.
Yeah, so what it comes to your mind when you see it?
I was thinking chemistry. Alchemy mixing.
Chemistry. Then what's your name, sir? Shu.
I see processing, how to put things first so you can feed all stuff.
Awesome. I like Shu. So he's helping me. See what he says, Shu says is, life is so important. If you put unimportant things first in this barrel or in this jar, you will not have space for important things, the blocks. You see this? In this jar, Shu put important things, which are the blocks, rocks. Then there is always a room, right, for the sand? Shu? So, of course, there will be also room for beer, always. Okay. So, in the sense, next 3 hours, we need to focus on concepts. We cannot just focus on, hey, what is the syntax for splitting the string, etc., etc., etc. So, what's your name, sir? Joseph. Hope you give me freedom, rather liberty to shake your hand. What's your name again?
Joseph.
Okay. How about you, sir? Kevin. Wonderful, Kevin. So look here. So this is very important. So please feel free to ask any question, but make sure it helps everyone. In the sense, the time is very important. 3 hours. A lot of people might be thinking, "Whoa, 3 hours. How can we sit?" I'm telling you, after 3 hours, you'll say, I can sit 1 more hour. Okay. So this is it. This is how we are going to do. We're going to have 3 hours. In between, we'll find some break. So 1 hour will be understanding big data, Lambda architecture, programming, batch data, big data. We'll do a little bit of Scala, a little bit of Apache Spark on Hadoop. Hands-on, as I talk, you'll be doing this. So 1 hour we'll do it. The next hour, we'll be focusing on real-time big data, streaming, Kafka, Cassandra integrations. I'll be doing, but you'll be watching. It's not recorded. I'll not play. I'll be doing it. Okay? So that it goes a little bit faster. Then we take the lessons from this and this. Then you are going to do hands-on again here, the last. Of course, as you all might be working in some software, you know there will be some glitches here and there. Iqbal, have you worked in any project there are no errors?
Every project has some errors.
Every project has. So there will be always. So we'll be fixing glitches, and some glitches may be specific to your laptop. That's why feel free to go for pair programming and sit with someone else. Okay, sir. I would like to know your name, sir.
Mark.
Mark. Awesome. And not only name, sometimes as I interact, please kindly share to, not just for me, for others, so what you're doing, in which department you are.
I'm with the Computer Center, and I work with a group called Research and Computing. So we help people who do any kind of research at the university.
Wonderful,
including
wonderful.
High performance computing.
Wonderful. I might ask names couple of times until I get registered, So, okay, wonderful. That's great. Let's move forward. So first our agenda. So I'm not talking about big data is 4 V's, velocity, all those things. No. Big data is big data. Everyone knows big data. See, but quickly understand. See, all companies have a lot of OLTP data, online transaction processing data, your employee data, your customer data, your financial data. It's just 1x data. Earlier, this is all the data. But things have changed. There is a 10x data. There is social media data. People are talking about your UAA. And people are talking about what's happening in your campus. What's happening. Great things happening in the campuses. Also, some unwanted things happening in the campuses. Everything talks because it's an open press. It's open press. So, weblogs, your company or you may have a website. People are coming and clicking your website. Your website can capture the logs. What's happening on your website? What's happening on the Amazon.com when people go and click? What's happening on the eBay.com when people go and click? You started a company with a great product. A lot of people are coming, Iqbal, but everyone adding products to the cart, but nobody checking out. Are you not worried? You are very much worried. So it's a problem with your product or problem with your checkout process. You want to know. That's why you want to process the weblogs, either in batch or in real time. Batch, if you are single, in real time, if you are married. Because your spouse may kick you. Your business is not doing well, you're not bringing money. So better do real time. Now, Iqbal. Okay? So look here. How about this? 100x data. It's more relevant for our university. Maybe some of you might be doing some research on genomes, neural data analysis. Yesterday we were attended high power computing. About whatever it is, research related data is always very big data. And the IoT data, and the videos, and the space, you know how much the video data, especially CC cameras, how much they help to identify the crime nowadays, right? Yes. So they're so important. Otherwise, even body cams. So they're so important. So if you want to process that data, it's a lot of big data. So it's just to say there is a huge data, that's it. So how 1x data is handled before? Please see this. This is how people used to do even now. It's not going to go away because 1x data will be always there. Some people think big data is going to replace everything. No. Big data is not going to replace everything. Big data, 100x data or 10x data, that has to be handled the way it should be handled. 1x data, employees data is not going to go away. Kiran, you are handling employees data, students data?
Yeah.
Kiran and Shiva works in analytics. They get feed every night. So this is how they get. Finance data, CRM data, an ERP or point of sales or students data. So they ETL it. Research data. What are the data? But it's not huge data, right? It's not huge data. So because we are talking about 100 gig. Okay. So you store in the data warehouse. They build the cubes. Then they do everything, budget planning, dashboards, all the queries. They either use SAP Business Data Warehousing or Oracle Business Data Warehousing, some tools like Cognos, etc. But if this is 10x and 100x data, they, first of all, when these tools are pulling the data, they will be very slow. You run a query and have to go to coffee. Iqbal, you might go for a restaurant to have a nice Indian food or whatever it is, Mediterranean food. So things have changed. To handle the big data, the architecture became like this. So you have a lot of source of data, 1x data, 10x data, 100x data, whatever it is. There's still somehow there will be integration layers. Please go a little bit high level, abstract level, don't go details, tools level. Some data ingestion, definitely, or data integration. The old 1x data definitely still goes here. They are not going to go away. They will be there. This 10x and 100x stack is here, which does the processing. They may have to filter, they may have to take some aggregations. So this stack will be serving the business. When I say this stack will be serving the business, they may give some data to data warehouse. They may give to big data dashboards, big data queries. Not only that, they need to serve advanced analytics. Earlier analytics is more like a dashboards. A lot of you know advanced analytics means even analytics is automated. The machines can learn based on the data. Machine learning. Or you want to do a deep learning. So you'll be doing deep learning. So, but after this data comes into, it is serving, it is called serving. I'll talk about that clearly. So, or your company may be building a data services, something like weather.com. Weather.com. Iqbal, you know weather.com?
Yeah,
What is that?
it gives weather based on locations,
From where the data is coming?
maybe some satellites, some processing.
How much do you think weather.com cost? The whole business.
I have no idea.
Yes, they're not going to hold your neck.
Billion.
Huh?
Billion.
Billion. 1 billion IBM purchased.
Maybe over 1 billion.
1 billion IBM purchased last year. You know, from where the data can come? Is somebody entering into the weather data? No. So some sensors in every city, right? Sensors are bringing into big data stack. Then they are putting into weather.com some NoSQL databases. That's not done. If data is there, but how you are accessing it? You are accessing through your mobile phone, right? It means they put a data services. Your mobile app is connecting to some API and you are pulling it. Right? Right, sir? I would like to know your name, sir.
David Henson. David Henson. Which area? Oh, I don't work for the university.
Oh, wonderful. So we have audience. Okay, David, welcome. Excellent. So what do you do, David?
I'm a data architect for a company in town.
Wonderful, wonderful. Okay.
I mean, I'm associated, I'm a grad student. I don't work for the university.
Doesn't matter.
Okay.
We welcome you very much. Okay. So look here. So this is how the stack is. But let's go to a logical architecture. Of course, this stack is going to use wonderful technologies. Hadoop, Cassandra, Scala. You can put this stack into the Amazon Web Services, or we have high power computing in the university. This is the core thing I want you to understand today. We'll discuss that. Before that, we'd like to know more names. We have new friends. Following statement is true. The previous statement is false. Wow. You are a philosopher. What's your name, sir?
Gus.
Gus. Okay. Which department you are?
Mathematics.
Mathematics. Wow. We talk about functions. We're talking about derivatives. We are going to talk about functional programming today. Scala. So, Steve, I know. Madam? Marian. Welcome, Marian. Student affairs. Okay. I know my associates. Razi, no. I met Tom yesterday. Very good. You, right? Sue. Nice. Very good. See? Oh, I came to know. Okay. So, Scully, my friend. Hello, sir. I'd like to again know your name. Ever.
Yes.
Wonderful. You want to share what you expect from this workshop?
I'm probably going to get rich.
If you become rich, please tell me how to become rich, okay? Okay, wonderful. Okay, sir. Great. This is the central. We are going to program this architecture. This architecture is a solution. We are talking about a solution. We're not talking about infrastructure, okay? A lot of people think architecture means infrastructure. No, solution architecture. So we are going to understand this solution, big Lambda architecture solution. You can apply these solutions at many places because almost 90% of the companies uses this architecture. So it's a open architecture. You go into Wikipedia, it says Lambda architecture, you get it. These are proposed by the industry standards. Try to understand, it's a common sense architecture. Let me move this.
Can you zoom it out to 50% perhaps?
Let me see. Good? Okay. Okay, very simple. Let's understand. This is critical for what we are going to do next. It's not a big deal. We have mathematicians, we have software. If you apply that, very easy. See, basically, this is the big data. Let it come from anywhere. It may be from sensors, it may be from cars, it may be from MRI scans, it may be from neutron stars, 1.6 billion years back, traveling, and now it reached, some people think last year it happened. No, they happened long back. So they came, but they have sensors which senses that. So data sensors. So finally, you're putting in the funnel. So putting in the funnel, you are going to put it somewhere. There are softwares. Please, excuse me, I need to put 75. Instead, I'll move this, okay? Some softwares like Kafka, Apache Kafka, or Flume, Hadoop, or Kinesis, Twitter. Don't bother about names, but they do the same. So like imagine, there is a big community where they have a water tank. The community is taking water from the water tank. Right? But there is a supply to the water tank, right? Supply of water. So why the water is not directly going to the houses? And why it is coming to the big overhead tank?
I'd say it more as like storage. So this way you can distribute that data out. Like, or as far as like, if it's like the concept of water, you distribute that water out.
Right? The source has water, right?
Yeah, we would distribute that water out if it's going to be in a tank.
But why a big tank? I can get from this one. Source?
Because it filters.
Huh?
Because it filters it.
No, let's put filter on the. Alright. Anyway, let's not waste time. You know, if this broke, tomorrow we want to pump it up, potential energy, MGH, convert it to kinetic energy or whatever it is. So there is a lot of advantage, right? It's a common sense way they design. Same way here. See, you don't send the data directly to the Hadoop. I'll talk about here. Some storage or some processing directly. No. There are specialized softwares which captures this data. So imagine now 100x. After a few years, there is a 1000x. As 1000x or 100x data coming, don't you think these should be highly scalable softwares, Steve? They should be highly scalable. Your water head tank, if it collapses because you're pumping water, will you stay in that community, Steve? Will you stay in that community? No. So they should be robust, right? So that's why these are powerful softwares. Earlier you might have heard IBM MQ series, TIBCO, RabbitMQ, some messaging softwares. Sure, you heard? You heard about those messaging softwares? Yeah. Those used to do 1x, 10x. But 100x, imagine the water head tank collapsing. Will you stay in that community, my friend? No, not at all. Don't even think a minute. You're thinking. Don't think. You'll be running away. So, these are not just pass-through softwares. These are powerful softwares that evolved to address the big data. So, which is Apache Kafka. Apache Kafka is a software which was developed at LinkedIn after they evaluating all other softwares. They wrote their own software and they open sourced. And the people who wrote that software went out and started their own company, and LinkedIn invested in that company. The only software company, the only company LinkedIn invested is Confluent, the company that supports Apache Kafka. And it is used by almost 90% of Fortune 500 companies. Of course, we have Kafka even in UOA. So very powerful software. It's going to be more famous. Fluent, there are some other softwares also. The Kinesis is Amazon Web Service, AWS, but same like Kafka. Everyone has their own. Twitter. Twitter is not a software. It's like a big water tank, right? It's coming. People will be pumping the water. People will be drinking the water, right? So that is also a source of a lot of water. Will Twitter crash, Steve? Will Twitter goes down? It used to 7-8 years back. If it crashes, they put a blue whale. Not the blue whale game, which is taking, unfortunately, a lot of youth life. Twitter whale. Because this is where we'll be understanding this software today. We'll be using it. So this is where the data ingestion. Okay, now, come on, a lot of data came. But these are just, you don't go and drink there. You need to tap it, right, my friend? You need to tap it. Look here, this is your house. This is your house. So you are going to store the data here. Say customer data. Apple has 12 million customers, or 100 million customers. 100 million customers. Okay. 9 million, 10 million, 20 million, 25 million, 30 million. So it is continuously growing, right? So they'll be appending every night new customers, right? So they won't touch, they won't change this. That's why it is immutable data. Immutable data. If they start changing this, you mess up. What happened? Where were you 10 years back? 10 years back, in which city you are? You are in Tucson or you are in Phoenix? 20 years back?
Yeah.
Tucson?
Yeah.
50 years back? Not in Tucson, right? So the truth table, hey, 50 years back, you was at this place. So this is immutable data. Immutable. Then so you want to store this data. Where do you store it? You need software, right, Steve? This is just pass through. So this is where you need a storage software, Hadoop. And of course, even Hive is a software which sits on top of Hadoop, but don't worry about it. Hadoop mainly stores the data. Okay, you store a lot of data, customer data or MRI data or planets data, etc. But what for? You want to process it, right, Steve? You want to process it. So you need a computing engine, computing software. Is that correct, Brett? You need computing. Storage, what do you do? My friend?
What do I do?
What I do? No, if you just store your wine in your home, what do? You drink, right? Imagine you are not drinking. You'll be just, what's the point of it?
Yeah.
You store 1 day, 2 day, 2 years, 3 years, 5 years. One day a friend came, hey, you toast, hey, this is 5 years stored in my home. Right? Ultimately you need to drink, right?
Yeah.
So that is where the computation comes into the picture. Right? So you need to process the customers. You want to know the Apple, hey, who are the California customers? Who are the people, Tucson customers? Who are the people buying the iPhone in San Francisco and activating in Taiwan? They track. Where did you buy? Where it was activated. You go to China and you connect it to iTunes. It knows from where you connect it. So they have a graph of where they are buying it, where they are going it. Isn't it wonderful? So you'll be surprised to see the graphs. Anyway, what I'm saying is, this is the master data. So you're doing aggregations. It means you're writing a computation here. Program. So how you are going to do? This is where comes into the picture Scala and Spark. I'll talk about other languages also. So Spark and Scala. You may ask me, what's the big deal? I can write any program, right? No. Why? Because these are not simple storages. They are Hadoop storage. You need to process the data in parallel. Iqbal, you have 2 minutes to finish your lunch. What do you do?
I'll grab some quickly.
You grab, but you don't have 2 mouths. Only you have 2 hands. Maybe you eat like this, Parallel to increase it, right?
Yeah.
To finish it, you won't feed him, right? You cannot use his mouth. It's your mouth, but only thing is you will have to use the multiple hands. Come on. Scully, what do you think? Okay. Look here. So what I'm saying is, these are the parallel computation. You need to do parallel computation, isn't it? Parallel computation or multi-threading computation is not easy. There are a lot of challenges in doing multi-threading. You are doing it, they concurrently mess up other data. Things will change. You're shuffling it, you're doing it. A lot of problems are there, multi-threading. If you're taking one file, you're processing with simple Python, with R, it looks great, and you may be thinking you're data analytic guy. No. When you're handling a 100 terabyte data, your programs all fail. You need to deploy in the multi-core environment, multi-threaded environment. You need to run in parallel. Okay, they look, even a few other MATLAB, few other things also claim they are doing good. they are doing good if you are doing some simulations. Imagine a mission critical data where not even one record should change. Then these things won't run. Even Java cannot do well the multi-threading. And I say it does well, but writing multi-threading programs in Java and Python is scary. It's a nightmare, people say. That's where the functional programs have come into the picture. You heard about functional programming? Heard at least? Heard? Everyone heard about object-oriented programming, right? Functional programming. Functional programming is a powerful way to do the programming, especially in the multi-threaded environment. That's where Scala comes into the picture. But interestingly, even though the product is on Scala, there are APIs available where you can write Python-related programs. That's why you don't get scared. Python is great. You are doing it. Excellent. But let's understand, we are going to touch this today because this product itself is written in the Scala. And it's a beautiful language. It's a beautiful language. If Java is this side, Python is this side, Scala has the best of these two. Best of these two. On top of it, it has a functional program. No, we'll talk about that. So this is where the computation comes into the picture. So I call that as a, okay, this, let me call it as a data storage. We all agree, right, Steve? This one, I'm calling it as data storage. Okay, now come here. Here, you are going to do processing. So I'll call it as a data processing. Is that okay? Right? Okay, this is data processing. So you do the data processing for what? So I'm doing a processing. I'm creating a view 1, view 2, view 3. What are views? Views means output, right? Output. Any output, you're seeing it as a view. Output. Or writing to a file, that is also a view. So the output. Steve, why you need output? You process it, because processing is all about you take input and outputs, right? Output. So you need to serve some needs, right? So this is where I'm calling it as a, so first let me call this as a batch layer. Should we all agree for this? See here, this is batch layer. Why batch? You put the data first on Hadoop, then you are processing it. It may take 1 hour or 2 hours, 1 night, 2 days. Yesterday somebody is saying 1 month. It used to run 1 month, one job. They reduced it to 10 days. Or 10 hours. It's a batch job. 1 hour. It's running. It's a batch job. It's a batch job. That's why it's a batch layer. But what do? Ultimately, you need to serve some need, right? Or Iqbal is looking at weather data. It's a real-time data. Do you think it's real-time data, Iqbal? When you look at Tucson weather, 72 degrees?
Yeah, almost.
Almost means 5 minutes almost or 10 minutes almost?
Maybe 15 minutes.
Okay, let's say 5 minutes. Still there is a delay. Does someone remember in 2000 Yahoo used to give stock quotes? They say 5 minutes delay or 1 hour delay quotes. They're not real time. If you want a real time, you need to go to investment site and get the steamers. It costs a lot. So anyway, look here. So you need to make the data available in the, we call it as a serving layer. Look here, where is the serving layer? Look here, serving layer. Okay, do you see this? So, but how can you write data into serving layer? You need a connectors, right? So first understand what is serving layer. A serving layer is also some storage, right? You may be putting the data in the Elasticsearch. Elasticsearch is a software where you want to search full text search. Or you want to store that in a NoSQL database like Cassandra or MongoDB, a lot of other NoSQL databases, or even Oracle, you want to put. So you are putting it here. So you need a connector. Look here, I use this word for this data integration. Is that okay, Steve, with you?
I'm not sure what it means.
Data integration. So I am taking the data here, I'm integrating into another software. So I'm calling this as a data integration, because here I said it's a data storage, here I said it's a data processing, here I'm writing into some other storages to do the serving. So what for it is used, business will decide. Some you may be using for searching, some data you may be using for dashboards, or even some people building a web services like weather.com. You're building a web services. You are doing app. If you search Iqbal for temperature in Tucson, if it takes 5 minutes, will you use that app? Will you use that app again if it takes 5 minutes? What you're thinking. So maybe you didn't understand my pronunciation. Okay. So you may be building a web services, data services. Business will decide that. But that's why I'm trying to understand. So you wrote the programs and you connected and wrote it to this. So this is a serving layer. See here, now what's happening? So your data is coming into the batch layer. There is a batch jobs running, which we'll be writing programs today, and writing into Cassandra or somewhere in the serving layer. You see the data pipelines? So this is data engineering. This is, what do you think, Steve? This is not data science. This is data engineering, backbone. Today you're sitting here so confidently. I know Steve is a very confident person. But first of all, before you have confidence, you have a good backbone. If you don't have backbone, your confidence doesn't help. So, this is a backbone for the whole data pipelines. So this is data engineering. So once this data is there here, you can do anything, dashboards or machine learning, data science, advanced analytics, or building a data web services, or single point of data. You don't want data to be available in multiple systems for lookups. Anybody in University of Arizona to look this public data, go to this API. Or first to this data, this system, that system, that system. They're going to 10 systems. It's a waste of it, right? So that's how they build the systems. So this is the serving layer. So this is good. Now what we were discussing all these things, we are understanding Lambda architecture. That's important before we write the code. So now let's come into the picture. This is all good, batch, but it may be 1 hour delay data, 2 hour delay data, or 1 day delay data, 2 days delay data. There could be some applications, say out of 100 applications, maybe 2 applications, CEO want to see the data immediately. Especially people are adding a lot of products to the cart, shopping cart, but they are not checking out. It's affecting company bottom line. Or you are doing a MRI scanning for a patient. The patient is a chancellor of another university. Hey, we VIP. Can't wait, we can't wait. It's mission critical. So as the scan going on, I want to see the patterns. So if the scan puts into Kafka, the data goes into Hadoop, then Steve has to tweak the program and has to write into Cassandra.
Steve won't come in. I need minimum 1 hour. He said, Steve, I don't care whether he is vice chancellor or anyone. I need 1 hour. Because I can't make it work, right? If it's needed, it's needed. So it takes time. So that is where you need real time. Now let me come go a little bit down. Okay. Look here. Few applications, we want to process it instantly. Do you see this? I call this as a speed layer. Do you see this? This layer, speed layer. So try to understand the speed layer. The data coming, it's not storing, it's flowing data. Streaming means flowing data. It's not staying. As it flows, it will be incrementing. 5 minutes back, 10 minutes back, 1 hour back. It's incrementing. So how you process it? How you process it? When I say process it, you might have to filter some data. You might have to do some aggregations then and there. You might have to do some processing and give it to dashboards. Do you get this? It's not complicated. So only the difference between this and this, here you store and compute. Here you don't store. As it is flowing, you need to process. Steve, you shouldn't drop single record. As it is flowing, you shouldn't drop single record. If it is MRI, if you drop couple of pixels, the doctor take a wrong decision. Here there is a tumor, they will say here there is one. Because the pixels, yes sir.
Well, I mean, even on ingest and stream processing, there's some amount of caching that takes place inlining on stream consumption. Any of the points where you're having stream consumption, there's going to have to be some caching there, probably brain, that sits there and consumes whatever data points from the stream that it's looking for. So I mean, it's not that it's completely immune from having storage in that streaming
That is correct.
platform. It's just usually done all in RAM.
I think that is a very good question. But if you observe, there is
It has to keep the aggregations and the relations. And
exactly. The catch is, sorry sir, your name please?
David?
David, what he says brings up a very good point. He says, hey, as this is processing, sometimes it may be difficult. You might drop few records. Or some machine fail. Now let me come to the point. Okay. Some machine fail. Somehow, somewhere, you need to cache it. At least few minutes of data. Or an hour of data.
Sure, but that's not what I was talking about.
Okay, let me come back.
All right.
So, as the data should flow, ideally, you shouldn't store any data here. Because the idea is not that. Because it's a stream, you should make it available instantly, right? You got a tweet should be available there. There is no intention to store. But technically, what if a machine fails there as you are processing it? So one record might drop. So temporarily, they might store that few minutes of data into the disk. If something goes wrong, they'll look into that and get it. Okay, now let me take the David question. Okay, David, can you please repeat the question again?
Well, I'm basically saying, so say you've got, some kind of, it doesn't matter if it's clustering analysis or whatever, setting inside of your streaming process. Any of those algorithms that you've got watching the stream, I mean, there's multiple ways you can do it. You can basically say, I only want you to run this analysis on 10-second chunks.
Yeah.
And just continually kick the result sets out the door. But there are some streaming consumptions where you basically say, I'm going to start this, and you're going to keep updating your aggregations, and you're going to keep updating your column operations until I tell you to stop.
Correct.
So those types of things, it has to be aware of the temporal data that's already passed by, otherwise it can't. And some of those processes say, use this as training data.
Yeah.
Change your algorithm as the stream goes by.
Correct.
So it has to be aware of the temporal nature of the stream, otherwise it can't do what it's supposed to do.
That is
So
correct.
In
So
some cases, you are caching data inside the streaming consumption.
correct. So that is a very good point. So the point there is business is driving it. The use case is driving it.
Right.
But ideally, if you see IoT data or general data, they'll be flowing. Or as you rightly said, the temporal.
Right, you basically pull out what you want.
Exactly.
You don't alter the stream.
Correct. You don't alter the stream.
You're listening,
Yes.
but you're not changing.
Right.
Right.
So you may be you may have to look into some models. Sometimes that models you may create there itself, or you might look up into some other storage for the existing model. But that's a good point. What he says, but the idea is not to store, but the business use case might drive some amount of storage. But again, it may be 1 hour or 2 hours, 3 hours, but not forever. Not forever, right? Okay. So it's a flowing data. So we are going to see how the data flows today and write the programs. And here also you see, you need to write it ultimately after you process the data, you need to write that data somewhere. Steve, is that correct?
After you process it.
Yeah, after the process. See, this is where you can write. So this is, let's not spend too much time now. This is what the Lambda architecture is. Lambda. So this is the major data, batch data. This is the whatever the delta, the real-time data. So here we are using Cassandra. So now you understood this. We'll take this knowledge forward to do the coding. Yes, sir. Any question?
Is there a quality control side of component to this architecture?
Yeah, there will be. This is a high level. There will be data monitoring, some other tools to see how they are flowing, governance, or how many might have dropped, all those things peripherals. David?
Well, I mean, anytime you get into NoSQL, then you lose ACID compliance.
Correct.
I mean, that's the first thing you need to understand once you leave an ACID compliant RDBMS. That's what he was talking about earlier, when he's saying like your 1x data land, that's usually your source of truth.
Correct.
Anything beyond that is a derived source of truth. It is not the absolute source of truth.
Correct.
You can monitor in stream or through your batch processing. You can sample it to try to compare back to make sure nothing has changed. But you kind of lose the complete reliance on ACID as soon as you go into an architecture like this.
Yeah.
But I'm thinking even in terms of like what happens in a real system where you do have a flag that goes off that something was lost, right? How does it?
That will be there always. It's a relative. Spark streaming and some other softwares, they see relatively 99.999.
Yeah.
So you can't see something missing. But anyway, let's move. It's already 1 hour. Hold on. 1 hour. So we are already 15 minutes delayed. Okay. So now take the question.
I see the two paths from source data to up to Cassandra. So is that mean I can pick anyone whatever is necessary, or it is always two paths exist in the system in general?
It's based on the use. See, you know how to come to UA from your home, right?
Yeah.
Nobody tell you, government won't tell you, you need to take only this road, right? It's based on the need. If there is a traffic change, you will change it. So let's not go into that. Our aim is to program this architecture. Now you understood at least this. So basically it has two components, batch and real time summary. But you're writing it to serving layer. Okay. Now we need to speed up a little bit. In between we'll take some break. Okay. Now see, what that does mean? This type of architecture will be used in many applications, like genomics related. Softwares are there, built on top of this stack. Apache Spark, Scala, Cassandra, Kafka. Go to this. This is from UC Berkeley, a very famous genomics software. they are improving the current genomic analysis very much. There is another software called Thunder project from some research labs. They do the brain activity analysis real time as well using this stack. Scala, Apache Spark, so they use Python also, and Kafka, Hadoop, all these stacks. And there are a lot of other softwares are being developed nowadays for the connected car. Certain softwares are being developed using this stack. And some companies building IoT software. I'll share this deck, even you don't have to know each aspect of it. Just high level giving, hey, this stack is used to build the softwares. IBM is doing a lot on this stack. They are building a lot of applications. I gave this URL. You have a reference. Okay. Let's get into batch. How we are going to do batch? The summary for the batch is data files sit on Hadoop. Partitions. This is a catch. See, Hadoop is a software. Iqbal helped us to understand how to do parallel processing, how he handled his lunch with 2 hands, right? So, parallel processing. When you're doing parallel processing, you need to handle this, you need to handle this, you need to handle this. So your data is not one chunk. Your data is pieces. It's a big file, 100 gig file. But these 100 gig files may be small chunks. Then you run your army to this. Process this, process this, process this in parallel. Based on available cores, David, based on available machines. It's like just a project manager. Who is project manager here in our... Anyone project management, doing project management? Yeah, Miriam. Oh, you've been there, done that. Yeah, if you have people, these people handle certain tickets, these people handle certain tickets in parallel. Okay. So data sits on Hadoop. There are various ways you get the data into Hadoop. A lot of tools are there, a lot of automation is there. We will not be looking into that. We'll be just putting some file into Hadoop. Our job is to write programs to handle it. Okay. Next, we'll be writing some Spark Scala jobs. We'll create some aggregations. We try to understand how the parallel processing works. This I will talk about it. Okay, everyone, can you, using your browser, can you type this and get the code? Let's do fast. Another 15-20 minutes we'll do, then we'll take a break. Go to that, open your browser. Take this code. Click that. You might get some error, but don't worry. Download that file. Maybe zip file. Unzip that. We'll be using the systems. Some of you, if you have it installed, you'll have to sit with someone. Your system is not working, we'll not wait to fix it, because by the time we fix it, 12 o'clock, it will be 12 o'clock. We don't want to have that situation. Yeah, please download it. Okay, can you start your virtual machine? Everyone should see this screen. I gave instructions to install. If you have installed, that is great. You can download that, and you can use even your local browser for this. Even you can use your local browser also. This is general code, you will be referencing it. Okay.
Can you show us that?
What is that? Oh, sorry. https://goo.gl/yjk/jp6. You will see two files. Just unzip that. You will have to see, Steve, that particular folder. What files are there? Can you read out?
There's a, I just had them open something, step one, you guys can pause it.
Can you got this file?
Yeah.
Did you open that folder?
Yeah.
How many files are there? There are 3 files?
3, yeah.
What is the first file?
Directions versus sheet.
Okay, directions first. Okay, directions second. And you have pom.xml, right? Okay, let's focus on directions first. Directions first. Now you go to this is virtual machine. This is where some softwares are installed. Do you have software on your machine? Otherwise you can sit with someone else.
Yeah, it's installed.
Huh? If you don't have, you can.
It was too old, it couldn't.
Okay, no problem. You can watch here. Anyone has software, Iqbal?
No.
Who has the software installed? Steve? Very good. Excellent. If not, just watch. Will be. Otherwise, you can sit with them. Steve, I will be checking with you for some time. Okay. So this is good. Click this. This is the terminal. This is Cloudera virtual machine, which has Hadoop installed. And we installed Kafka and a few others, but I'll go to that later. First, you observe this. This is the Cloudera virtual machine. First, let's minimize this. This is the browser. This is the browser. Clicking the browser. Just click that. You will see here something called Hadoop. Can you click this? When you click that, you will see HDFS name node. Hadoop is a storage. It's a file system, but it's a distributed file system. Hadoop distributed file system. Iqbal, is Unix is a file system or not? Unix. Yes, right.
Yes.
Unix is a file system. You store files in it. So it's a file system. Actually, they say file system. Unix is a file system. But it's okay. So basically, it has folders, it has files. Because Unix is one machine. Now imagine you have 100 machines. So your file system is distributed. Now imagine these 100 machines have one operating system. Can you imagine this? Even our Windows you have C drive, D drive, right? Sometimes multiple drives. Operating system is only one, Windows. But your disks are C and D drives. Now imagine 100 machines, not 100 disks, 100 machines. Imagine each has one disk. Imagine these 100 machines are coordinated, connected physically, coordinated by a software like Unix. You can closely think Hadoop as a cluster operating system, but storage, not the resource management system for the cluster, for file storage. That's why Hadoop distributed file system. Steve, file system means it manages the files, folders, files. So in Hadoop, all data will be stored as files. There won't be any tables. In Oracle, you see the tables. In NoSQL databases, like Mongo, you see the documents. In Cassandra, you see certain tables. So different tables, columnar tables. But Hadoop, no, you just store the files. The files can be CSV files, JSON files,
Parquet files, ORC files. There are different formats of the files. Even if it's 100 gig or 1 terabyte file, 10 terabyte file, it's a file. But the file also, David, can have header. It has structure, right? File also can have structure. It is CSV, there will be header. It is JSON, there will be name value. Some formats have a built-in schema. But anyway, let's not get into that. We can talk later. HDFS, click this HDFS name node. Hadoop, click this HDFS name node. See utilities and browse the file system. We want to browse the file system. What is browse the file system? Means see the file system. Iqbal, browse the file system. So, Steve, do you see this? User. These are folders. See, D. User. Go to Cloudera. See here. So this is a folder. User Cloudera. User Cloudera. There is no files available. No files available. So we are going to move some files into this here. Okay. So how we are going to do that? So I'm going to use this Unix. In Unix, you can create directories, right? Just like a make directories. First, let me see here. I hope everyone has this folder. If you have already done that, you might have already. Steve, did you download some files?
Yes.
Okay, excellent. Do you have these files? SFPD, SF San Francisco Police Department,
Yes.
and trip data, some trip, New York taxi trips, etc. It's a big file, some 2.4 gig file. This one, it's not too big for big data, but for sampling. This is okay, it's some 20 MB file. Okay. Now we are going to move this file to Hadoop. So first let me create a folder. So anything you are interacting with Hadoop, you'll be using Hadoop FS. Hadoop FS, Hadoop file system. Minus mkdir, I'm making a directory. Under user Cloudera, I'm making a folder UIT. So I'm entering this. It will create one. I'll show you how it creates. But this is available here. If you want to copy and paste in your instructions, see Hadoop FS, mkdir. This is available here. Now, Steve, I'll go and check here now. See, earlier there is no folder here under user Cloudera. I'm checking here now. See here, UIT folder. This is a directory. I'm going there. There is no file here. If you see here permissions, a lot of things are there, but observe this block size. Block size. It means a big file may be put into small blocks so that it will be available for parallel processing. So Steve, now we are going to move a file, 2 files into this folder. Okay? So you have the syntax, you please see here. See, you'll be again using Hadoop, but you'll be using Hadoop FS. Copy from local, whatever the file you want to move to this folder.
One second.
Yeah.
You need to remove the space after the FS, after the hyphen on Hadoop FS space.
Oh, this one. Okay. Yeah, that's a good point. Okay. So let me go here. I'm again now. Steve, are you with me? Hadoop FS minus copy from local single quote the file name. I'm moving trip underscore data underscore 1 dot CSV. I need to move it to user underscore cloudera underscore UAIT. Is that correct? So I'm just entering. Let it take, the file is moving. As it goes into the Hadoop, I just refresh this. Just see what is happening. See here? Do you see this? It is copying. It is copying. Steve, do you observe that?
Yes.
Is that statement true, sir? Again, I need to know your name again. Gus. Gus. Okay, good name. Okay. Jay, Iqbal, it's copying, do you see? Let it copy. Let it copy. Let it copy 2 gig file. Yeah, it's done. It's done. If you see here, Gus, you see here, this size of the file is 2.29 gig, but it says each block size 128. So how many blocks will be there? This divided by this, right? So let me go back. Yeah. Okay. Let me click this now. Scully, are you with me? Okay. So now I'm opening this file. Opening it in the sense I'm just clicking and seeing. See the number of blocks. Gus, please look here. There is a blocks here. Block 0, 1. How many blocks are there? See, 18 blocks are there. It means there are 17 multiplication 128 MB. The remaining size is other block. So Hadoop does that. Hadoop does on multiple machines, or even in the one machine it does. So basically the same picture, if you have to see, this is how it is. Look here. I'll make this 50%. Look here. Hadoop. You give a file to Hadoop leader. This is name node leader. In the cluster, there will be worker machines. This is worker machine, data node, data node, data node. This is the name node. So we gave the file to this name node. So Hadoop software that distributed the files into multiple blocks. See, block 1, multiple blocks. Please observe. Hadoop is a distributed file storage. Now what happens if this machine goes down? If this block goes, that's a problem, right? So Gus, do you have a resume? Do you have a resume?
Oh, resume?
Resume? Have you ever lost your resume?
No.
Why? Because one copy will be there in your email, one will be there in the hard disk, one will be there in the jump drive. Right? That's what I do. So it means it should be fail safe. So there are multiple copies. So Hadoop, what it does is, not for each block, it makes the copies also. So what does it mean? Look here. Look here, Gus. See this? There are 3 blocks here. This is red, green, yellow, orange. See here, there is a red one here, you see? So even if this machine goes down, if this is not there, what happens? If this machine fails, this piece gone. If this piece has gone, means your file has gone. So that's why Hadoop does the fail safe. You may ask me why machines fail. What's your name, sir? Kevin. Forget it. Sorry, I'm lazy. Okay. So Kevin, where do machine fail? Yeah, why a data node fails? But if it's not, right? It fails, it has to fail. Because even human beings fail, right? Oh yeah. Right? You get sick. Mission easily fail. So not only that, these machines are commodity hardware. They are not high-end machines. If you have a 1,000 node cluster, 1,000 high-end machines, sometimes high-end machines cost $500,000 and plus machines. That was the problem for Google. So they started creating software which can run on the commodity hardware. Even this can be a server. You stack all the 100 machines, it becomes a cluster. But they failed. But good thing is we can also replace. We can easily buy another, right? If it fails. So that's what. If a node fails, you can easily plug and play. Then whatever the other copy will be replicated, so that you will have your cluster is fail safe. So number one, your Hadoop cluster is a fail safe. Number one. Number two, it's a horizontally scalable. Horizontally scalable means you have a big data, you want to process it slow. What do? Put another machine. Put another machine. Horizontally scalable. You want to go fight with 100 people. If you can't scale, what do? Bring more people, right? They call, hey, come on, man. It's not math. We need to fight. Yes? What is it?
Yeah.
So you need to more mission. Yes, David.
Well, I mean, basically this is just RAID architecture, only they're doing it at the machine level as opposed to the disk level.
Right.
I mean, your name node is basically your RAID controller, and you're just doing, like, if you think about RAID 5, you've got basic 3-disk RAID 5, you've got data parity.
Correct.
You lose one of the disks, you put a new disk in.
Correct.
Rebuilds, yada, yada, yada. This does the exact same thing. So my question is,
Yeah.
if they're removing compute
Yeah.
out of the Hadoop,
Yeah.
do you not see a time where they're basically, because really all this is IOPS then.
Right.
So you could just build either a RAM disk scenario or an SSD scenario
Right.
or some other, 3D architecture type
Right.
storage
Right.
to give you the IOPS, set a RAM layer over the top of it, and
Right.
you don't even need this anymore.
Right.
You literally go back to the monolith type build, only it's just a really fast monolith.
Right.
So
what's your question?
this is a RAID a la mainframe from like 40 years ago. Only they're doing it with servers as opposed to disks.
Yeah, see, the computer is the same.
It's not magic, is what I'm saying. It's basically.
No, the architecture is not magic. But the magic is, that is not a mainframe. The magic is, it's not just a disk. It is as a computation also. It's a commodity hardware. Because Google doesn't want to do magic. Google want to serve, when it created this one, with less money, it want to do a great search for you. So the idea is, they don't want to buy $1 million machine if it fails. They may fail once in a year, but still they don't want to. Instead, they want to buy from Dell. So it's a commodity hardware. So anyway, I'm not here to say this is a great architecture or not. The debate is not to prove this is great or not. This is what it is. It is being used in this one. How to program this, our agenda. Okay? David, will you permit me to move forward? No? Okay. Then I'll move forward. Otherwise, they don't permit me to go out. Okay, just kidding. Okay, guys, that's a good question. Anyway, the idea is, see, for us, now we need to think from software point of view. Forget about hardware. You don't care about RAID, you don't care about mainframe. It's a software world, guys. Software. You don't know where everything is, computing is a utility now. Steve, agree?
Everything's utility.
Utility. Yeah, you can go to Amazon Web Services, spend $100. In next 1 hour, you can have 100 missions. $100, 100 missions. Next 1 hour. You can tear it down after some time. You don't care whether it is a mainframe or, that's not a discussion itself, it's purely software. Now talk about it. Now, what your software need is highly scalable. You want to add 100 more machines? Should be in a position 2. That is horizontally scalable. Number 1. Scalable as far as the storage, scalable as far as computation also. Please note. Number 2, it's great and it is scalable, but not fail safe. Gus, your data is not safe. Forget, man, I'll do on paper. Highly scalable, fail safe. That's what Hadoop is. Now move to our programming, our agenda. I'm available to discuss, and even I want to learn. So I'm just sharing what I know. That's good. So 11 blocks you have seen. Hadoop distributed file system, it distributes. Now let's compute. Let's write program to access this file. Let's write this program. Kevin, let's go to your this one, Cloudera. Maybe open another tab. Open another tab. How you compute? Scully, how you are going to process the data? The data in the Hadoop.
Probably gonna write some code to
Right.
pull it out and manipulate it.
Correct. So Hadoop doesn't accept any code. So Hadoop IO compatible. Should be Hadoop IO compatible. So it's a parallel processing frameworks. It supports MapReduce, which is old, going away. It supports Spark and a few other frameworks. But mainly the leading is Apache Spark. So now let's open that, Kevin. Open the Spark shell. Just like you open your Python shell, David, we're going to open the Spark shell. So it take this, let's spend 10 minutes before the break. So look here, you copy this. Spark shell, master, we are using local machine. Master means computing master. We are loading some packages, like CSV parser packages. I'm loading some packages, means I'm going to, that file is CSV file, please note. The file we have moved there is CSV file, comma separated file. To process that, I'm using that parser. I'm loading that parser. So I'm just pasting this here, entering it here. It opens up just like your Python, when you say Python shell, it opens up Spark shell, let it open. Kevin, can you do that? Can you copy that? Your Spark shell is open, it will open, it will be, that's good. That's good. Kevin, you're fast. Steve. Sorry. Kevin, right? Yes. Kevin, you are confusing me, man. Excellent. Okay, Steve, that's good. It opens up the Spark. In the shell, it loads those libraries. It loads the Spark library. It's actually Scala Spark shell. Scala is a programming language. Scala is a powerful programming language. It's an object-oriented and functional programming. Scala runs on top of Java. So behind the scene, it's all Java. It's all JVM.
every company has JVMs. As far as Java, there are three things. JVM, which is Java Virtual Machine, which is a runtime environment, JRE. Then Java libraries, great. JVMs are great. But the Java language is not great when you come to multi-threaded environment. So that is where Scala uses JVM, great, uses Java libraries. It has a wonderful syntax, wonderful abstractions. I'll show you. But this is Scala shell, but it is Scala Spark shell. What is Spark? Spark is additional libraries. Why we use Kevin libraries? Libraries help you, right? Libraries help you. Now see, you're sitting where, Kevin? Where are you sitting?
The libraries.
Chain.
Chain.
Why do you need a chain? Earth is there, right? This is a library. See, you don't want to sit on earth because you don't want to hurt your back.
Yes.
Huh?
Yeah, otherwise like the floor is uncomfortable.
Yeah, when you take a beer, okay, that's a different matter. You sit on the floor. Okay, this is a library. It is helping you to do something. Okay, come in. So, okay, please observe, when you load this, there are two objects are already available. What are those objects? SC. Please enter, Kevin. SC, Spark shell, not Spark shell, Spark context. Spark context. This object is available. See, arg.apache.spark, this is nomenclature, Spark context. Spark context is available, SC. SQL context is also available. SQL context is also available. Okay. Now, Kevin, let's connect to that file. How you write Scala programs? I'll share some info, but first let's start writing. Val means some variable. Kevin data. Kevin, are you with me? Kevin data. Spark context dot text file. This Spark context has some methods to access the file. Text file, JSON file, Parquet files. Get it? Okay. Text file. F caps. Text file. Where is the file? Where is that file, Kevin? Where is it? Huh? Yeah, Hadoop. Excellent. Kevin, you're doing great. So, where in Hadoop? Where is the address? It is sitting in Hadoop file system, like HTTPS, Hadoop file system, on a name node. What is the IP address of the name node? Let's go to this browser. Steve, Hadoop, name node. Look here. Do you see this? This is the host. This is the host name. Gus, this is the host name. On that host, Steve, in which folder it is? Under user, under Cloudera, UAIT. What is the file name? Trip underscore. What is that?
User.
trip underscore data underscore 1 dot CSV. Right? So I'm declaring a Kevin data variable. Kevin data variable. Now we're writing program, computation. K data. Suraj, K data is a variable. What is data type? Whenever you declare variables in any program, you need to know what is data type. Some programs like Python, they may not give you the data type immediately because they don't infer the type because they're not compiled languages. Java, Scala, C++, they're compiled languages. When you compile itself, it checks the type. So start focusing on the type. Whenever you are declaring some variables, just make it a habit. Hey, what is this type? Is it is it a string, or is it an integer? Is it an array? Something like that. Look here. K data is, this is nomenclature, don't worry. See here, RDD of string, RDD of string. So you need to understand what is RDD. I'll make you understand. But first why we are doing this, we want to first connect to the file and see what are the partitions. Right? How many partitions are there? 18 or 19? 18 plus 0. 18 plus 0, how much, Suresh? 18 plus 0 is 19. 0 is 18. No, here in software, 18 plus 0 is 19. Math, okay. Okay, look here. Awesome. K data has a partitions. Partitions. My system is a little bit slow. Don't worry about the syntax. Just see what it is doing. That K data has partitions. Those partitions are there as as an array. That array has length 19. Steve, isn't it cool that here you have 19, you have already seen 19 blocks. 19 blocks. (18 plus 0, 19). 19 blocks. See here, 19 blocks. They're able to connect. Now quickly see. See this shell, the program you're writing here, you want to monitor a little bit what is happening. Actually, what is happening here, Steve? You're writing a program. It is interacting with the file, right? It is interacting with the file. Let's do this. But first, let's go here. Go to the browser. Say localhost. Say 4040. In the browser, you can see, hey, what is happening with the jobs a little bit. Localhost. Go and see your Spark jobs. Kevin, every program you're writing, every line you're writing is almost like a job. What it is doing? I want to count how many rows are there. It's like a job, right? A computing job. Look here. I'm clicking this here. Okay, that's okay. First, let me go here. This is Spark Shell UI. Whatever the Spark, this is Spark Shell, this is UI. Now let's do, Steve, let us count the rows. let's take some rows out of it. Let's do count. K data has a function called count. It's RDD. So when it is counting, what it should do, Tom? It should go to all the partitions, count this, count this, count this, count this, then aggregate, right? So literally 19 jobs it is. 19 jobs, Steve. 19 jobs. So actually it's one job, 19 tasks. 19 tasks. But are we doing parallel? Are we doing parallel? Let's observe. Because when we started the Spark shell, we started local bracket 3. I opened 3 threads. It means I can run 3 tasks at a time. 3, 3, 3, 3. Let's see. Then we'll take break. I know you're feeling sleepy. It's heavy, but let's do count. Come on. Enter. Go to your this one. Refresh this. This is doing. See, it is doing 3 at a time. But let me see here. It will show you this count is running. It is 0, 1, 19 tasks. 19 tasks. I'm opening up. Let me go there.
Okay, so I just ran the Unix command line WC and counted the lines, and it was like 10 times faster than this.
That's correct. What you've done in your local system, right?
This was on local server though, so it's.
No, local server because this is a classroom. But if you are taking a neutron stars colliding, you put on your server on Amazon Web Services, and you may be having terabytes of this one. And moreover, counting is just to see what is happening. The whole idea is not to count.
It's just example.
But you're counting counting a terabyte file is different. Counting local file is a little bit different. Yeah, who is that? Okay, let us observe. Let us observe this, guys. This is very important. See, the pulse is important. Your doctor holds your pulse. What does it? What it gives?
It's for get important information, triage, see.
What is there? Just pulse.
It's a heartbeat.
Exactly. So you just get the sense of it. Parallel programming. We are trying to catch the program. Parallel programming. The concept. See here. Now just to count how it is doing. You please observe. I went inside. Now see the task. Steve, do you see the tasks here? Task ID 0, 1.
Yes.
How many tasks are there? Please see. 18 plus 0. 19. Sorry, Gus. You're violating mathematics. Okay, let's see. Now please observe. Timestamps. Gus, please observe this. Task. Please see the timestamp 25, 25. This is date. See 22, 22, 22. See 35. So it means the 3 tasks ran at a time. 3 threads parallel. Please observe. Next, 35, 35, 35. Gus, do you see that? 35, 35, 35. 3 more tasks. 5 plus 0, 6. 6 tasks are over. Next, 39, 39, 39. Next, 42, 42, 42. It's okay. Few seconds. changes based on sometimes one task is waiting, etc. So Kevin, before we take a break, what is the lesson? What is the summary? What Hadoop stores a file, can be terabytes, can be even petabytes, as a distributed file storage. You can write programs. You can connect to the Hadoop cluster. This is the clusters of many machines. So I just used, it sounds like a laptop, local machine, but you think logically software. This has a server, this has a threads, etc. You can see when you connect to your website, Amazon.com, Steve, how many machines you are hitting? Do you know where those machines are? You don't care. You see it as a single entity Amazon site. It may be sitting on 100 machines, boxes. The backup of 100 may be in Tucson, Albuquerque. One machine goes down, where it routes, you don't care. It's the abstraction, right? So see the logic. So you wrote a program, you went to those files. You did a simple count. But the idea is not to do count. The idea is to check how the parallel processing is done. We did a lot more steps up there. You did parallel processing. Now imagine, your cluster has 1,000 node cluster. You have terabytes of file, thousands of partitions. You submitted a job, it's running. There may be hundreds of tasks. They allocated number of cores for you, threads for you. So processing will happen. Yes.
So a couple of questions. You didn't specify a size for the partitions, so is the default 128 megabytes?
David.
Yeah, and in fact, it behooves you when you're setting up your nodes. They tell you to do JBOD on each one of the nodes, but you want to be sure that you've got block alignment on all the disks to match up to that. It sounds like some easily translatable way. If you do 128 straight up, that's a good way to go.
So second question is, this implies to me that Hadoop understands the structure of your files? It doesn't. So
there's danger in that too.
So it chops right across in our case, since it's CSV, it chops right across the record then?
It doesn't chop vertically, horizontally, yes.
Well, yeah.
So
for each row, it's going to chop a row at some point, right?
No.
No?
Row. One row will not be in two partitions.
But will half a row be in each partition?
No, not really.
This might answer your question. Don't imagine that the blocks are completely full.
Yes. But how does it know where to chop?
It's a software, the intelligence it has. It makes sure. So basically, it's a row.
So it does know what the structure of my file is.
You want to take.
Well, yeah, because it's a CSV file.
You want to take equal
It has to know it's a CSV file,
Right.
therefore chop at the end of line.
Right.
Yeah,
Tom,
okay.
you want to take people to lunch. I also want to take him lunch. Either you take or I take. You won't chop him.
Right.
You won't chop him.
I understand that.
Where is intelligence?
I understand that.
We have the intelligence. The software has the intelligence.
Right.
It makes sure
Right.
your row, either I take this as David mentioned, need not be accurately 128 MB. But it reserves 128 MB. Reserves 128.
So what file types does it understand?
It's like just like your Unix, any file you can code it actually. So, but generally,
But no, that doesn't make any sense, because if it has to know where to chop, then it has to understand what's in the file. So it can't be any file.
no, anything is a row.
Anything
It
is a
has,
row.
yeah, like JSON has a name value, but again, it's under the hood, it's a text. It's a text.
So you're talking about a line feed, carriage returns, and new line, end of line?
Correct.
So.
Maybe.
In a way, you are right, actually. It uses the
It can do two things. So say you have an MP3 file and you throw it into Hadoop. Hadoop can totally hold it. Don't think of its splits as data aware. Think of it as blocks on a hard drive. So like you can have disk fragmentation on your hard drive and your MP3 file can be held in 6 different locations on the disk. But the file system is abstracted away from how the block behavior happens on the disk, right? Okay, so you can think of the same thing. So there are certain types of files that Hadoop is aware of, and those serialization patterns it understands, and if it sees one of those, it'll split appropriate against the row space so that it can efficiently go back and read the data. But if you throw a data file in there that it does not understand, it'll still hold it.
Right.
It just may not be the most efficient thing in the whole wide world reading that file back, other than just a dumb read.
Right, so if you want to be parallel, so I guess that gets back to my question, which file types does it understand?
I don't know all of them, CSV.
See, the idea is, usually business drives, usually, as you mentioned, CSV files, your JSON files, Parquet files. Parquet means there is a compression files, which has. We'll do one thing. We can even pull the data. So it's 10:51. We'll take 10 minutes break. We are running 30 minutes late as of now. But fine, but because this is a foundation, many times when you build a building, foundation takes more time. But after that, we'll quickly do it. But you guys are doing great and nice discussions, Tom and David. Let's take a break. Okay. 10:52. We meet at 11 to 10 minutes break.
Thank you for doing this. Huh? Thank you for being
Cool, man.
Yes, thanks. So you have been with UA for 4 months. 4 months with UA.
Yeah. Well, that's not true. Go to Einstein's, or even just go to the Mark. Hey, Mark. Start the Starbucks line. It was.
It's okay.
I mean, that's probably right. Like, it's 100 in a different file, so we're connected to it. This is what's, it's like,
That was the one we're gonna have this.
so that I given the commands so that you can even do at home. See, I moved a file, San Francisco Police Department CSV file onto the Hadoop. I'm going to connect to that file quickly.
So, do you mind, I
Yeah.
wanted to clarify something from the last session.
Yeah.
So I thought I'd draw it up just to make clear.
Right.
So we're connecting to this Hadoop cluster, but it's passing down the computation to each partition, is that correct?
Exactly.
So it's running a count on 0.
Correct.
And then it's aggregating up here.
Yes, exactly. Awesome.
Thank you.
So that is managed by Spark, right?
Correct.
Parallel processing.
Correct.
But what happens when we need all data together? For example, for counting, it's fine if you count individually and sum up somewhere.
Yeah.
It's fine. But for it's considered graph database. So for graph database, doing some computation, you need all piece of data together. So how did we do?
So your idea is not to bring all the data into the display. You may take data.
But I cannot. Problem is I cannot compute locally.
No, you're not computing locally.
Okay.
Brett, that's what you mentioned. Your computation is there on the cluster, on worker nodes. Each one take its own load. Just like we are all army. You are taking your load, I am taking my load. Then project manager will tell it, you took all the load, now take this load, data, some of the data, and put it into the Cassandra.
But to complete my job, I need some other data also.
No. Your job is your job. You cannot do my job.
So I'm talking about graph data.
Hold on.
Yeah.
Your machine, your partitions here, your task, you are doing here. You are doing here, you are doing here. Okay, one question. Then comes the picture. You have aggregations.
Yeah.
That is a different task. At this time, you need that data. You are doing some data, not some data. You are doing aggregations. Then you need to get this data here, all these things happens. So aggregation means mixing, shuffling the data. That is also a task. That is also a task. So it goes and do it.
So individually, doing something and aggregating something from some other places.
Correct.
But if we handle graph data, graph data, that is not CSV file. So in graph data, if you compute something, you need to see other neighbor.
Right.
What do you mean by graph data?
Graph.
Network data, not CSV.
Graph, he is talking about graph.
Oh, okay.
But again, you need to see graph also, you ultimately, a graph is a adjacent nodes. But there correspondingly, you can convert it to a table form.
I can convert it to a table form, but think about shortest path. We have a big graph where I want to find the shortest path from here to here.
Yeah.
So I cannot compute anything locally.
Right.
I have chunk of data in this table, you have data, but I cannot compute anything from locally.
Right. So, well, make it very simple. It's not rocket science. See, one software is doing it means you are just doing on the cluster. Okay. So you do what you can do on local. You do what you need to do shuffling. It's basically only two. Just local and shuffling. I'll come. Only these two in the computation. You do here or you get from there. Whether it is a graph, whether it is ultimately is a data structure, right? Either linked list, anything is a data structure. Your computation algorithm will be there to handle it. So it is there in the network. So this software will have the ability to do it. It's a network. That is where the idea is there will be two tasks, local tasks, shuffling tasks. There's a shuffle, I'll show you the shuffle. Just give me a second. Yes, sir. David, you are mentioning something.
I misunderstood his question.
Okay, please observe. I'm importing some library.
CSV parser. Now I am going to load the SFPD police department data, a CSV file. I'm going to use a parsers. This time I'm not using Spark context. Instead I'm using SQL context. I'm taking the file, parsing it. I'm not doing low level programming, high level. I'm taking the file and converting it into a table. Converting a table in the computation itself, not on the hard disk. Hard disk in the sense that's not a literal Oracle table. The table exists only for that computation. Please observe. Look here. SQL context. Where is the file? I moved that file. Kevin, I moved that file. Yeah. Then it has a header. It has a delimiter. In one line, this software has the abstraction to parse the file, to read the header, to split the string, to make it as a table. Please observe. Very powerful programming aspect. You go and do this on any file in any language. Look here. In one line, this SFPD became a data frame. Data frame means you can think it as a table, which has the schema. This came through header. It has the incident number, category of the crime, what is the description of the crime, day of the week, date of the one, where it happened, etc. Now please see here, SFPDDF data frame, show 10 rows. Sorry. SFPD data frame, show. See how powerful it is. It constructed a table. It constructed a table. So your computation read the file. Imagine this file could be across many machines, many blocks, but your computation sees it as only one file. Behind the scene, there are many. It may do many tasks, but when you are seeing it outside, you see it as one. Now look at this is I got the table, a few rows of the table. It's just getting it. When I'm getting it, I can go there and get it. I can go there and get it. And go there and get it. There is no issue, as Iqbal said. Iqbal says, when you are shuffling it, what it does. Yes. Let me do some aggregations. When I say aggregation, say some top 10 crimes, something like that. Let's see. Let me do it. So this particular data frame I'm selecting one column, category of the crime, distinct crimes, and I'm collecting those data and bringing it onto the screen. This is also, there is no shuffling involved. Why? Distinct of this partition, distinct of this partition, distinct of this partition. Just append it, right, Iqbal? No big issue. You got this many unique. Now I'm counting. This category, how many? This category, how many? Kevin, what we need to do? So what happens in the cluster? Imagine when you have many blocks. So this category, there may be four crimes here. The same category, maybe 3 crimes in another block. Same category, 3 crimes in another block. Right, Steve? Now, for this category, how many means? I'm going here, 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 mixing them. There is a shuffle involved. There is a shuffle involved. Please see.
how I'm going to do. So this is one way to write the syntax. What is that? So you're taking a data frame, writing the syntax. Some people who are familiar with R, they are comfortable with this type of syntax.
So this is the syntax of Scala.
The syntax of Scala. You would see the chaining, data frame, select, dot distinct, dot collect. It's a functional programming. Scala is a functional programming. It will help you to chain these commands. But a lot of people come from SQL background. SQL background. That's why you can create a table. So instead of data frame, actually data frame is a table, but literally for a computation, you can register a temp table. Please see here. I'm doing that. What I'm doing is, please observe. I'm taking this data frame, I'm registering a temp table, sfpd underscore table. Now access this table as if you are accessing a Oracle table. But it's there in the computation. Please see how I'm doing it. So I am now can write the SQL. Please see. SQL context, I'm writing the SQL. Select a distinct category from this table. That data, I'm collecting it and displaying it using for each. So this is also distinct. Same thing which we have done earlier, but using the table. See the syntax? You created the table, select a distinct category. It's a simple syntax. But now I'm going to the top 10 crimes. So I'm going to the, what are those resolution? How many counts are there from this table? So this is where I am taking two columns. Resolution of the crime, how many counts of the crime. Let me do this. Then I'm grouping it. Look here, this arrest book, there are 2393 are there cases, juvenile, different things. So these are the aggregate, please, David.
So what is the complexity that you can execute inside of those quotes inside of your SQL context? I mean, can you map like 6 different tables and do joins? And
well, that's a good question.
Does it allow for
Yeah,
layers? Does it allow for
it allows. There are certain restrictions. The idea is in Hadoop world, they try to minimize the joins, but you can go up to almost 10 tables. Because when the file reaches Hadoop itself, it's a lot of flattening is done. So that's where there are some restrictions.
Well, I'm just saying it's a schema on read environment. So
Schema on read.
when you're going back in, you're trying to relate the data. There's only so many ways you can try to relate the data. And
correct.
It's going to be a join.
Correct.
So, or a cross apply or something like that.
Correct. But again, as much as possible, they flatten it before coming itself. Okay. From here in OLTP, if there are 100 tables, by the time these 100 tables go to Hadoop, they may become 10 tables. They won't copy table to table.
Oh, I know. I'm just saying.
Yeah.
If you're looking at a data lake.
You're right.
And you've got data in there for 15 different subsystems. You've got stuff in there from your web servers. You've got stuff in there from your network devices.
Correct.
And you're trying to do time correlation.
Yeah.
You're going to have to join at some point.
Definitely. Yeah. Yes. Tom.
So when you created the data frame,
yeah,
where did that get created?
Your data frame, it's on the cluster. It's a computation.
So a cluster has a memory. So the data frame has a pointers to the hard disk. But interestingly, you can cache it. If you have enough memory, you can load the whole data, you can cache it. Especially if you are doing a machine learning type of iterations, you don't want to go to the hard disk every time.
In memory.
Bring it in memory, so then it will speed up 10x times. That's a good question. Okay, if you see this, now you can do, ultimately what you understood is, now you have a file, the Scala Spark, you can access it, the CSV files, Parquet files, JSON files, you can make it a schema-like, dynamically. Then you can do the aggregations. What are the aggregations you want? Those aggregations you can write it to Hadoop, or you can write it to Cassandra, some other data stores. That is the whole idea. Any questions, David? Okay, guys.
So,
yeah.
any computations you do at this reader, essentially REPL, you're doing it, you have a Scala read eval print thing here, right? Any computations you do here are being parallelized, or?
It's parallelized on the cluster. But when you bring it, when I'm collecting it, I'm bringing it to the driver node, the driver program. Okay, quickly, I give you a few Scala constructs before I run few other programs. In Scala, you can declare the variables as val and var, but val is immutable. It means val name, say Kevin, it's suppose the type is aware. You see here, it infers the type. See, name is string. Val is equal to some 26. It's aware. The type is integer, you please see. I'm declaring a data value. Data is equal to an array of, let me take this. I have in some syntax. Some few friends are here who can help you. See, I have declaring a data, an array of string. This is one string. This is another string, another string. So basically, it's an array of string. This data, Scala offers a lot of built-in functions, higher level functions, which will help you to process this data, to get into this. Say, for each, you can iterate. So data, imagine. So what is happening? See, this looks like a file for you, right? Isn't it? Imagine this is billion rows. It means these billion rows can be imagined as an array of billion rows, billion strings. See here, this is a record. This is a record. Andy, employee number 123, Los Angeles, he loves it. Want to go to Hollywood, Andy? Matt, a colleague, Shiva. This is how the data looks like. Think this is a string. Hold a minute. This is 4 strings. 4 strings. Imagine they are part of an array. Now imagine a file of billion rows is an array of billion strings. But since they are on the distributed cluster, this array is a distributed array, a parallel array. So Scala handles these distributed arrays concurrently and parallelly. Yes, Iqbal, please.
So, data is in RAM, right? The data variable.
This data is yes. This data is yes, but not the billion rows. Billion rows will be each machine's RAM will be using. When you collect it, you use the I/O.
only you could able to pull what is possible. But of your process, you can push it to some other systems through the network. Okay, good. So if you see here, then let me see here. Data, let me take another data. Val, new data. New data is equal to array of numbers. Say 1, 2, 3, 4. This is just a Scala array. Scala array. So n data, it has higher order functions. Map. You take one element of this an array, any element of this array, x, you map it to x star x. Gus, you know this now. A function, x is a domain of a function. The function is mapping to the square of that function. Fx is equal to x square. X is the domain and x square is the range. So the function is square function. So you literally, it's a transformation you're mapping. Function you're mapping from, look here, sorry. Where is n data you declared? Not found n data. Scala is case sensitive. Look here, this array, you got the new array. You don't have to say for each this number, you don't have to write the for loops. They do the higher order functions. So map is a higher order function. And higher order function can take a function. Look here, instead of x square is a simple, but let me define a function. Let me call it as a Gus square. That takes an element x, which is an integer, and it does something crazy. X, I don't know, it does this. This is Gus square. It squares but multiplies this. Okay? I declared this. See, GSQ is a function. GSQ is a function which gives our output. 4 into 4, 16, multiply 2, 32. So the function, you declared a function. Interestingly, in the functional programming, you can pass the functions around your program. In Java, you cannot pass, but in Java 8, you can pass. It becomes more functional. Python, you can pass using the lambdas. You heard this lambdas, Python lambdas? Python lambdas is a functional program. You can pass the functions. Look here, I'm passing. N data is an array. For a map, I'm taking each element of this map. Map is a transformation. I can take a domain of a mathematical x, can pass it to any function. Now I declare a function which is Gus square, right? Look here. Earlier I just mapped it, but this is a function somewhere I declared. So I'm passing it. Look here. I got this output. So literally what I'm doing is I'm passing this function. So you can freely pass the functions around. That is a functional program. Anyway, we can slowly have a special interest group. If you want to get more interest, we'll help you. So let's move forward. So this is how Scala syntax will be slowly you can able to acquire. But let's go quickly. So what we're going to do is, let me know, since you've done some batch, you've done some aggregations, those things you can, just like a Python, you can write into editors also. So you can write in Python shell and also some editors where some text files you can open and write. Like that, for Scala, You can use Eclipse. Eclipse is more popular for Java environment, but Scala, Eclipse plugins are there. So I have given you the instructions you can do at home, but let me run this. How it looks like, let me show you. This is how it looks as Scala editor. So let me do some real time quickly. What I'm going to do is I have a Twitter program. So in the when you write programs in a shell, you have some advantage. Some libraries are already loaded. When you write into your editors, you need to import those libraries. Because ultimately the idea is just we need to package this program and deploy it somewhere, right? So these are not what you call, these are standalone programs. So they should stand by themselves. Rather than the shell, it's a restricted environment. So, okay. So look here. So how, I'm taking a Twitter. Twitter is there. So here, let me make this a little bit visual. So this is how a typical programs looks like. You import libraries that are needed. These are Spark libraries, okay? For every program you write, this is needed. So you import those libraries. What are the libraries? Spark streaming libraries, configuration. Okay. What is this library? Twitter. Because I'm connecting to the Twitter, I need a Twitter connector. So as you asked me. Yeah. If you're connecting to Kafka, you need a Kafka connector. If you're connecting to Cassandra, you need a Cassandra connector. So Twitter. This is some logs, managing the logs. Okay. Let me go. A typical Scala program is written as a object, your program name. If you are writing a Scala program in a shell, not shell, sorry, in editor, you need to write it as object program name. Object program name. Okay. So that program name, just like C, it needs a one method minimum. That is the main method. See here, this is the main method. This is the main method. So all your code will be inside that main method. Okay? Okay. This is the main method. This is logs I'm suppressing. Don't worry about these lines. What is this? I'm going to connect to the Twitter. So to connect to the Twitter, you need some security, handshake. You need to go to your account. You need to create some security keys. Twitter allow you security keys. It authenticates you. You are good to go. It will say. It will give you some keys. I need to set up those OAuth keys. OAuth keys here. This is what I set. So this is also standard for any program. Your Spark, you are using Spark shell, Spark libraries. You need to create Spark configuration, Spark context. Also streaming context. When you load Spark shell, your Spark context is already loaded. The SQL context is already loaded. Since this is a standalone program, because we need to create this context, the configurations, Spark configurations, which master you are using. This is streaming context. In how many seconds you want to pull the Twitter data? Every 2 seconds I want to pull the Twitter data, right? This is what. This is where exactly heavy duty is going on. The Twitter utilities. The connector has a library called Twitter utilities. It creates stream. So that is where it connects to the Twitter. Then it gets the data into the hashtags. So I'm getting the Twitter status messages, get text, the status, I'm filtering it. I'm only bringing the tweets that shows love, because a lot of people will be always writing some messages. I hate my love, something like that, whatever it is. So then I'll pull this and ultimately print it. Okay, print it. I need to start this program and I will terminate it manually. So I'm running this. To run this, I'll be using this. Run as Come on. Scala application. Let's do this. It's running. So it start a connection established. Right now in real time. Right now in real time. This is what people are talking about there. Let's say you are still the cutest, humblest, kindest, loveliest. Okay, retweet. Bad news. I accidentally watched a nice. Okay. I fell in love once and I feel like no one could ever make me feel. Self-love is not selfish. This is happening right now there. Right now. Right now. Okay, let's do one more. I'm stopping. Let's do because we need tweets. So let's see what people are talking about our president. Okay, it's not our data. We're just bringing it. At this time. Let's see. So a company launches use cases. Apple, Samsung launches a product. Say 2 in the morning. So people want how the buzz is. They want to talk. So they get the tweets. Not only they get the tweets. Let's see. What's happening? Tom, what's happening there? A lot of retweets going on. Okay, now the company launches the product, Samsung launches this products, they can get the data and see how the buzz is. As you run this data, some people who do research like Tom, they can add additional libraries like natural language processing libraries. Tom, your team is doing some NLP? Okay. They can infer the meaning of these tweets by the words, good words, bad words. They can create a quantitative sentiment dynamic. There is no human intervention. But they need to do this engineering. First, they need to get the data from the pipe source. Then on top of it, they will be running those libraries. Then they can display to the dashboards or they can store. Toyota do lot of this. What type of talk going on about the Toyota? About the brakes, about the repairs, the purchases, all the data they will be pulling. And they do a lot of sentiment, a lot of information. So you need to understand. So what you did is, you wrote a Spark program which you connected to the connector and could be able to pull what you want with the data you can decide. So it's basically stream processing. Then you may put that into a Cassandra, whatever it is. Okay, let's do. Yeah.
Can we try hashtagging also, like hashtag?
Yes. What hashtag you want? But somebody should post, right? You need to make sure. Okay, let's say Twitter. But what is time now?
11:35.
11:35. Okay, let's see here. So you need to catch the. Anyway, I think I can't experiment now. So let's go here. You go and do it. I'll share the program. Now let me go. Now see, I want to connect to the Kafka. So this is Twitter public forum one, the Kafka. So what is Kafka? Yes, sir. Tom.
The streams that you created, these are streams in Spark or Kafka streams?
Twitter pulled from, Spark pulled from Twitter.
Right.
Now we're going to pull from Kafka.
Right, but when you pull from the Twitter stream,
Yeah.
the Twitter feed,
Yeah.
you created a stream.
Yeah.
Data type there.
Yeah.
That was a Spark stream.
Spark stream. That's a good question. Now let's go. See, what is a Kafka? Kafka is integration broker. Integration broker. There will be producers, there will be consumer. In between, the Kafka guy will be there. This is the bad way of integration of the systems. Instead, LinkedIn suggests this. You give it to a one broker. Who wants to take from that broker, they will figure it out. So that they decouple these integrations. So Kafka is a broker. There will be producer and there will be consumer. But again, this has to scale, means there should be partitions, right? Partitions and parallel processing. So this is where the files will be, even the streams also ultimately, there's a files, because they stay there sometime in the Kafka. This is called time to live, TTL, 1 day, 2 day, temporarily. But again, if the server goes down, your streams goes. That's where you again need a cluster environment. Kevin? Cluster environment. So if one broker goes, other broker will be available. But it writes only, okay, when you write to this and this, but what is this? You're writing this and this. Are you writing to partitions? You need high level abstraction. It means you write your topic. Just like we gave the file to Hadoop, Hadoop split it. We didn't go to each machine and write it. We gave it to Hadoop name node, that distribute. So in Kafka, all the messages will be given to topic. Topic means errors topic, logs topic, warnings topic, customers topic, students topic, employees topic, some queuing mechanism. Okay, sir? So let me go here. So you have a software where there is a Kafka. So I'm going to start the Kafka first. Okay. So I gave the instructions. There is a quick start guide in the document. It's a very simple step. Download the code, which you already downloaded the code. You start the server. Zookeeper is a management software which already started because your Hadoop is there. Second step is not needed. But in the second step, this is where really you are starting the Kafka server. Okay. If you do this, it will say it's already running. Don't worry about Zookeeper. Zookeeper means keeper of zoo. Okay, a managing software. So I'm starting the Kafka. Kafka server is running. Then I'm going to, I already created a topic. So I will see what topics are available. This step is to create the topic. This step is to list out the topics. I already have the topics. Let me list out the topics. I created in Kafka 2 topics. UIT logs, L capital, UIT logs, small letter. So I'll use this topic, small letters. So this topic, I'm going to post some messages to the topic. Tom, I'm going to post some messages to this topic. Let me, topic is UAIT logs. So I am going to post, means I'm creating a producer now. So that producer gives me a console. That's console. Now this is where I'm manually putting some messages because I don't have Internet of Things. Ideally, there will be some tools which will be sending the messages. Okay, let me do it. First, let me meanwhile prepare my program. Here, I have a program here. Okay. This time it is not connecting to the Twitter Tom. You see here, you have Kafka connector here now. Because now I'm going to pull messages from Kafka. I need to use the Kafka connector. If I'm getting from Twitter, I will be using Twitter connector. So okay, I'm using a Kafka connector. So the same, you need the configuration, streaming. So you need to list out what topics you are reading, and what brokers. Then there is a function, Kafka utilities, just like a Twitter utilities. Kevin, Twitter utilities, just like Kafka utilities are there, which can read. I'm going to post some messages. I'm going to split those messages and do a word count. Okay. I'm splitting my messages, and finally I'll do a word count. I'll put some messages. Each messages will have words, right? I'll split it, words, how many words are there? Like that. So, and I will print it. Okay, let me not write to Cassandra first. Cassandra, I will show you. First, let me display it. Let me display this. Okay, I'm going to run this. First, let me run this. Then I will post the messages. Oh, it's not coming. I need to rush because we have short of time.
So Srini, there's a class in here at 1. So if you want to try and run over and everyone's willing, we could stay a little bit longer, but I've also reserved a room for next Wednesday from 9 to 12. If we want to do part 2.
Oh, wonderful. We'll talk about that. That's great news. First, let us spend these 15-20 minutes. First, what it is. So see what's happening here. You see here. This is running, Tom. This is running here. Every 2 seconds, it is connected. What happened? Am I still running? I got some data. Let me see. Okay. So I will go to. Let me see which program is running. Is it Twitter program or which one is running? Okay, it's a Kafka program. Okay, let me post some messages. Okay, shall I copy this, Tom? Tom. Okay, let me take this. So this is where the program is. This is where the Kafka producer is here. I'm going to post this message here and enter, quickly see what is happening here. See here? Words and count. Again, I just type the same. So whatever, let me copy some from our UA website. Okay, UA professor. Where is my producer? Kafka producer is here. I'm posting some messages. And so what it does is it took the sentence, each line, it splits the pieces and counted, aggregated, and displayed. Okay, now what I'm going to do is I'm going to write this into Cassandra. See our unified Lambda architecture. See here, I'm reading this, I'm going to write into Cassandra. Okay, so let's pull up. I'll stop this. I'll let it run. That's not a big deal. So I need this Kafka. I don't need this. I'm closing this. So I am going for, everyone has, you downloaded Cassandra. I gave the instructions, it is there in your instructions. I'm going to start the Cassandra, okay? What is Cassandra? Cassandra is a NoSQL data storage. It is also highly scalable. All your Netflix streaming is on, what is that? Cassandra. Cassandra is a cluster. Your iCloud, iTunes, everything is there on the Cassandra. Apple is the biggest, Apple has a 30,000 node cluster running on the Cassandra, which hosts the petabytes of data. Okay, let me start the Cassandra. Where is my Cassandra? CD Apache Cassandra, this is the 2.8. I'm going to sudo the super user. I'm going to start the Cassandra server. Marian, I'm starting this. Starting the Cassandra server. Cassandra is like a just NoSQL database. So interestingly, it also has a client like SQL Plus. SQL Plus, you can connect to your data store. Kevin, I'll show you. Let this start. Your Kafka is running. Cassandra is getting started. Let me see if I can first connect to SQL SH, Cassandra query language shell. It's connected. Cassandra, just like you say table, you say table space in Oracle. In Cassandra, you call it as a key spaces. Describe key spaces. What are the key spaces available? Okay, I have a key space December 19. Let me use October. Use October 24 key space. Key space means table spaces. In this, what tables are there? I have word counter. Select star from word counter. Think it for some time as a just Oracle database, just like Oracle database. It's a data store. Steve, this is I have a simple table. What is the word? What is its count? I'm deleting the rows. Truncate word counter. My cursor is not working. Select star from word counter. Now no rows. Steve, now it's clear. No rows here. So now what I'm going to do is I'm going to post the messages. In the Spark, I'm doing the word count, then going to write here. Okay. Let me show the picture speaks better than words. I think this is okay. See here, Steve, I'm going to post some messages here, okay? Those are going to Spark streaming. Here I do the word count. Word count is big for natural language processing. In page ranking, Google page ranking, words, and in machine learning, DF algorithms. What page should be ranked, etc., especially in the search. Okay, so this the word count, I'm going to write it to Cassandra. Steve, do you see this? So my Cassandra is up and running. Kevin, so I'm using I need to use Cassandra connector. Yes or no, Iqbal? Because the bits won't fly. Okay, that's good. Okay, so here. So let's see, where is my all setup? So this is my program. This is my Kafka. This is good. This is my Kafka server. This is my Kafka where I need to post the messages. I'll stop this. This is retweets, so it's coming retweets. Let me run this tweet. This is my Twitter is stopped. This is stopped. Let me see. This program is stopped. I'm going to my pros. Okay, this one. So it's 11:53. We'll do up to 12:10. Then we'll discuss the plan. First, at least continuous. Is that okay? 12:10, 12:15. Okay. So okay. This program is running. This is connected to. No, let me go back into this program. Let me do some edits. See here. This has Kafka connector. Kevin, Kafka connector, and also see the Cassandra connector. Data Stack Spark connector. This Data Stacks is a company which supports Cassandra software. Cassandra is a very powerful software. It is originally produced by Facebook. They wrote the software and gave to the world. And they wrote based on Amazon Dynamo. Amazon has a NoSQL database called Dynamo. They created the software and they gave in the specifications. Based on those specifications, Facebook created the Cassandra software, taking some more ideas from the Google file system, not Google file system, Google BigQuery. There is another paper they released. I have a big story about NoSQL databases. When we meet maybe next time, we can talk actually. There is a big story how the whole NoSQL movement happened. Okay, let me go. So I have a Cassandra connector, Kafka connector. I am writing the word count. I already printed, but this I am uncommenting this. Whatever I'm printing, that's all okay. These word counts, thus I'm saving it to the Cassandra. There is a method for this word counts. I'm saving to this key space. In this key space, there is a table called word counter. In that word counter, there are some columns, word and count. So earlier, you remember word and the number, we are printing it, right? I'm taking it and writing it to Cassandra. Okay, awesome. So I'm going to run this. Let me save this. I saved it now. Let me run this. Okay, let me open this so that what it is doing, let's see. First, we haven't posted any data. First, it should connect to Kafka. It's connected to Cassandra also. See here, it connected to Cassandra. Nothing has written. It says 0. See, wrote 0 rows. It says wrote 0 rows, you see. It hasn't written anything but it will be continuously doing it. Looking, hey, is there any data? Is there any data? Is there any data? Is there any data? Should stream, right? So now let me post it, some data. Let me take this data again. Where is our producer? This is our producer. And third, I went to this. See here, it says how many? 7 rows. It skipped actually. Let me go and see. This is where, right? Earlier there are no rows. Now I will see whether we could able to write to Cassandra whatever we have. You see this? So now what happens? Suppose same data again comes. This counter, the Cassandra has a wonderful column. It's called counter column. Even though you insert, it increments the count if the key matches. Suppose, see, what if I insert gain again? Gain 2. When you insert, that's why it's called upsert. Cassandra, it updates your insert, the keys matches what Oracle says. Oracle says unique constraint error. It cannot insert. But what Cassandra does is, that's what it's called, upsert, UPSCRT. It updates actually. The key matches, gain 2, again gain 2 I put. Oracle does not allow, it says stop, unique constraint, because the word is the key. But here when the keys matches, it goes and updates. Since this is counter, this is the counter, it adds. If that column is not counter, when we declare a table, when you create a table, let me go here. This is how you create the table, see please, in Cassandra. See here, when you create table, what is the primary key? Count as the counter. If I say count as the integer, it updates. It updates. Suppose say gain 2. Next, gain 4. 4 overwrites. It becomes gain 4. But if it is counter, Steve, what happens? Gain 2. Now gain 4. 4 plus 2, 6. Let me come back. I think I confused. Gain 2. If it is not counter, you're inserting it. What should happen? It should update, right? Gain 2. Now gain 4. Gain 4 overwrites gain 2. So gain and 4. But if it is counter, now see the scenario. Gain 2. Gain 4. What is the net result? Gain 6. So the 4 plus 2 will be added. Counter. That's why it's called counter, type counter. Okay, let me do that. So here it's gain 2. Now same again. I am just copying this. Sorry, where is my browser? Again, I'm copying this. I'm going to again. It says written. Let's see. This is gain 2. Let me see. Kevin, you see, gain 4, gain 2 plus gain 2, counter added. Just see. Anyway, the summary is this, simply see here. You understood this Lambda architecture, which is industry standard. It's a lot. In 3 hours, you understood this. You could able to sit without throwing stones on me. It means really, really you did great job. Trust me, people spend at least 2-3 days to capture all these things. So you understood Lambda architecture. You understood various components like storage components and computation components. Then serving layer, Cassandra. Then you also understood that there is a data ingestion layer with Kafka or Twitter and some other software also. There will be connectors. Here we did a streaming exercise. We have a streaming program, which you did it, you could be able to connect here. So give me 5 more minutes. We'll do a quickly Apache Logs processing. Logs processing. Okay, look here. I am going to So lot of customers come to sites like Amazon Log, Amazon site, etc. For companies, the customers will be clicking this product, this product. Each is a click. Each is a click. So when you click, most of the websites in the world are powered by Apache Web Server. Apache Web Server. So they capture some logs. Those logs are called Apache Logs. So they have a fixed formats. So to parse those logs, before you do anything, you need to parse. So there are libraries available to parse, just like a CSV parser. There are Apache Logs parsers also. So that code we have. So first let me uncomment this. So I don't do these word counts anymore. Let me comment this. I'm not doing the word counts. Instead, I have a code. I will give it to you. Kafka util. This also I will comment. So this I uncomment. I use Kafka util. This time, what I do is I have a logs. Bear with me. See here. Please bear with me. Gus, please see here. I am getting a log. How a log look like? I have given in this code for you. Let me give you 1 second. This is where some sample logs are there. This is a very good stuff if you show to any of your friends who is exploring some big data. This is the Apache Logs. Looks like a what timestamp. What is the IP address from where the hit is coming, the user, at what time, what they're doing, they put or get those HTTP, what is the URL, clicking, and something I don't remember, I'll quickly check, some information, what is the size of that byte or etc. 401, this is the status. This one is the size of the, let me see.
Probably the overall package.
Possible, yeah. IP address, content size, response card. Okay. So, Gus, please see here, I'm going to get that from Kafka. I'm reading it this time. Each line is a message. So, this is a string message. Kevin, this is a string message. I pass this string to a parser. Parser means a helper, which cuts this Apache log and properly adjust it and give some structure to it. Because you may be wondering why we need structure. See, they are not just like a CSV files. You see here, they are little bit crazy format. They have, even see brackets. You see here, dash. So how they parse? We don't talk details, but you might have heard regular expressions, regex. Regex is a big topic where they identify the patterns. Anyway, so I have a parser here. This is the message. This message, Marianne, I'm going to pass to a parser. This is my program, one parser program. That parser program has a method function, which is a parse log line. If I pass that line to it, it will give a beautiful output. Just like I created a Gus square function. Look here. So I have a Scala program, a simple Scala program, which has an object. It does this pattern recognition, like using regular expressions. But don't worry about the details. Just see. What this is doing is, this has a function or method. Please look here. It is taking an input, which is that log, each log line. Iqbal, what is the output it is giving? It is giving a log object. What is this log object? Log object is here. See, this is the log object. Log object has a structure, the table structure, IP address. Look here, IP address. These columns. See, even in a table, if you talk about a table, your table is like a class. It's a blueprint, right? In this table, you are putting one row, second row, third row, fourth row. David, is that correct? This table is like a class blueprint. Then each row is a record, which is an object based on the blueprint. It went like a cookie cutter. Cookie cutter is a table, and you cook your cookie based on the cookie cutter. Each is a row. So the cookie object, cookie cutter is blueprint. Cookie object is the object. Okay, look here. See here. See the beauty. It is taking a input log as a message and giving output as the log object. It is doing something inside. Finally, it is giving. So don't go for the details. Anyway, this is the parser. So look here. I'm exactly doing that. I'm passing that to the parser. I get the output. Then whatever the output I get a beautiful output, which is a structured output. I am going to save to Cassandra. Tom, I'm going to save to the Cassandra. I have a key space. I have a different table here, Apache log table, a different table, which has many columns like IP address, client ID, that structure. Since I passed it, I passed it to the Apache log. I got the output. Then I can persist here. So let me see my Apache log. Please bear with me another 5 minutes. So select star from Apache log. It has some data. Let me remove that. Truncate table Apache _ log. From Apache. No data, please. Your Apache logs. See, what happens is you stream the data, you persist into Cassandra. Maybe Kiran and team, their analytics team, they may be running some dashboards on it. Who is clicking on it? See, you capture the real time, but you may not be analyzing it in real time. Please try to understand. Catching and storing it. Some people may store in the web server itself. Later they FTP the files, then process it. I'm not going to the details. Okay, let's see, guys. Okay, let me run this process. This is my process now. Let me run this process. It's going to read data from the Kafka. Then it is connecting to the Cassandra, but it is trying to write it to, see Apache logs, you see here? 0 rows to Apache log. So no input, no output. Now let me dump some Apache logs. So you see, I'm just copying here, okay? I'm copying some Apache log here. I copied just for test. Kevin, are you with me? Are you mad? Okay, I'm safe. Okay, look here. I am my same Kafka, same topic I'm writing. I displayed also. And it said how many rows it has written. Actually, it is okay, awesome. So let me go here. 8 rows. 8 rows. Let me add few more. Let me add few more. Got it? How many it has written? 15. Man, you're seeing very fast. My cursor is not working on this shell. That's why I'm copying here. So earlier 8 rows. 8 plus 15, 23 rows. Please see how it's happening. Now imagine extend this to IoT application, Internet of Things. From Southwest Airlines, they are tracking their aeroplanes data every 10 minutes. Thousands of airplanes. They are tracking in real time, they are collecting the data. They want to predict the maintenance. For next week, this airplane needs maintenance. They're not maintaining it at the time. They're predicting it so that the downtime is less. So they take the valuable data, then can do analysis, nightly analysis. Or if some mission critical, they can do as it is streaming itself, they can do it. And last point, the scale doesn't matter. We have no respect for the size of the files because we have powerful tools. Hadoop can scale at any level. The Spark also uses the cluster, computing cluster, RAM, just horizontally scale, fail safe, computing, powerful computing these abstractions, thread safe, functional programming, and a lot of people can comfortably write programs. Please see, if you see, the programs are not complicated programs. The lot of is a templates only. Only 4 or 5 lines, that's it. 4 or 5 lines if you see. So imagine you're taking it, putting it to Cassandra. Then, no, you give it to us, you may be running some more on it. So, you as a data engineer, you'll be creating a backbone, data pipelines. It's like a crude oil you're taking and refining it, giving gasoline. It goes to Costco, it's useful for many, etc. Any questions? 5 more minutes questions, then we'll have a plan how to touch base.
I have a question.
Yes, sir.
So Cassandra doesn't use distributed file system, right?
That's a good question. It is not a file system. It's a data storage. It has its own, it's actually sorted map. So it is a columnar data structure and it is distributed. Everything, any cluster is a distributed. Any cluster has to be distributed. You heard about CAP theorem? You heard about CAP theorem? Okay, good. Let me share one small slide for you, since you asked a very good question. I need to talk literally this next time, maybe we'll have. This is what it is. Please see. This is not. Look here. In theoretical computer science, the CAP theorem, consistency, availability, and partition tolerant. David, you might have heard this. Brewer's theorem. It is impossible for distributed computer system simultaneously provide all 3 of the following guarantees. You can have these 2. If your application has consistency availability, you will be using this availability. So availability is fail-safe. What is P? Partition tolerant. So every distributed system, you take now everything MongoDB, all our clusters, otherwise they can't scale. The whole idea of NoSQLs came because of this scalability. Even the Oracle also does cap partition, but it's a nightmare to maintain it. You need millions of dollars because they are not designed originally for the cap, only for C and A. Whereas a lot of applications, not to replace Oracle, there are applications which doesn't need immediate consistency. Eventually there will be consistent. Something like you go to hotels.com, you're trying to book a room. It says rooms are 10 available. Maybe 9 rooms are available. By the time you start booking for 10 of your friends, including me, because you like my lecture and you want to sponsor me, hey, 1 book for Srini. But when you're checking in these 5 clicks, and you're checking, it might say, oh, sorry, this room is not available. Anyway, I don't want to have so much debate about that. But any other question? Tom? Kevin? Steve? Did I bombard a lot of content? I know, but I truly appreciate understanding this. Trust me, go and talk to anyone. It is MIT, Stanford, or UC Berkeley. They are discussing these things. So truly appreciate yourself for spending this time here. Go and confidently talk basics. We are not talking about syntax, etc. So I give 1, 2, 3 instructions how to do it, etc. Okay. Any other comments? Brett, you want to tell post plan or how to help further?
Well, if you want to continue the session next week, we can do that. It's really up to if you have time and if people are still interested enough to meet.
Okay, we'll plan. Brett will continue, but probably we might have some SIG, special interest groups, so that because my suggestion to you is don't lose this foundation, because everywhere next to 10 to 20 years you need this. So you got this foundation, so you can start picking up Scala. And you can write even Python programs in Spark, which is easy, just in a couple of hours. But why I did Scala is the product itself is written in Scala. That's all. The next, Cassandra, Kafka, all those things, everywhere everyone talk. Any big system, they're building big distributed systems, we talk about this. David, you know how different companies are using this. At least you heard this, right?
Yes. I've worked in 3 major industries, and yeah, I know how to use it.
Awesome, yeah. Steve.
So you were saying in your opinion, I've heard of RabbitMQ before, you were saying in your opinion that's not substantial for these types of.
RabbitMQ is here, it's great for 10x data, maybe 100x data. 1000x data, Kafka. There is, I'll share the comparative charts.
You'll get into some shops where they will sit there and have active arguments between whether or not JSON or XML is the most optimized format inside of the file for transmit, right down to the millisecond of how long of a difference each one will take on transmit and ingest. So it really just kind of depends on the use case.
Yeah, so that is scalable.
And they'll throw binary JSON on top of that and have that too.
So I suggest you to follow. I shared all the slides, etc. also, especially if you are doing research. Follow certain things called, this is genomic research, Adam. It's built on all this stack. About DNA research. They use a lot of these stuffs. The Spark, as David, right? David mentioned the formats. The community is consolidating the formats, especially the DNA data. They consolidate on Parquet files. So big files. Parquet have a schema built in. The file has schema. and also it's a compressed. And they can read for I/O also very fast. Next, any other question? Yeah.
If you don't have the slide on the download link, could you post the slide on the download link so we can review?
Yeah,
the
yeah.
slide?
I'll check. I'll find a way to send the link through.
Okay. Yeah, I know the IT summit will take a couple days.
Sure. Tom, any other question? Any comments?
It actually will be a lot quicker. It'll record, it'll render, and you can send out that link. If you find it interesting. Within an hour or something.
David, any questions, comments? Okay. Yeah.
This Cloudera virtual machine that we're using, was that so that Hadoop was set up for us already and stuff, or are there other sort of?
Hadoop is set up, Spark is set up. But there are a few things I gave the instructions, but you might get a couple of glitches here and there. I think that's where. So what is the plan for somebody is interested in the coming? I love to do this because I've been doing for quite some time. So Brett, what do you suggest?
I'll create a channel on our IT6 Slack team and make sure when you leave, if you haven't signed in, do so. So I'll have your information, I can invite you to that Slack team, and I think that's probably the best place for us to continue, decide if we're gonna meet or distribute everything. Sound good?
Okay, excellent.
Thank you.
Wonderful.
And if we just want to stop Prompto from here.
You can shoot me an email, my svemula in case you need some information.
How is it?
What do you need?
To open up Kafka. It looks like it's open somewhere.
What's that? I already did it.
That's it. Just hit the stop.
Right now.
I have to stop it here before I stop it over there.
Awesome.
Thank you so much.
Hey, nice, man. Great.
Yeah.
You use LinkedIn?
Is that?
You use LinkedIn?
Yeah.
Yeah, I connect.
Yeah.
So how many years you work at